Hey guys, we're going to be talking about the endocrine system in chapter 13. So you'll need to know these bulleted items about endocrine glands. And the thyroid gland is one of those, so you can see how they are different from exocrine glands. You can also see here that we want to take a look at this list here, how they're different from the nervous system, because we know the nervous system causes actions in the body. So this is how the endocrine system is different from that. The chemical communication, how that happens. Of course, that was the nervous system. And then this is just a picture of how the endocrine system works. You're going to need to note, I'm sorry that this is covering these names up, but this is the pineal gland and this is the thyroid gland. So you're going to need to be able to know where these are in the body. The larger endocrine glands are noted here. And of course, that's pineal again, right there, and what the hormone action is. You do not need to know, you don't have to memorize this information here from table 13.2. There are two parts of it, but you might want to take a look at it and see the names of some things, because then when you look at some actions later, you'll see how that maybe works in your own body. That can be interesting. We've got some steroid and steroid-like hormones. So these are lipids, and they contain rings of carbon and hydrogen atoms, is that word that's missing there. These all come from cholesterol, so cholesterol is not necessarily a bad thing. The sex hormones and the hormones produced by the adrenal cortex are steroid hormones. Non-steroid hormones are these types here: proteins, amines, peptides, and glycoproteins. And then again, here we've got types of proteins, types of hormones. Don't need to know these structures here. The actions of hormones, you can look at these two bulleted things here. This is what they're doing here, and get these definitions of upregulation and downregulation. Steroid and thyroid hormones. So how do they act? You might want to think about trying to understand this sequence. Could you could you put that in order or something? And then this is just a graphic of that same information, so you can process that. And then here in non-steroid hormones, the hormone is considered a first messenger, and then you've got a second messenger. So that second messenger, and we're going to see that over in the next picture. So here, this is where that second messenger sort of comes into play. You might see one of these diagrams in some of your online work. All right, you know what this clinical application. So look at this. You can read this in your textbook. Steroids, you guys all know how, people have used those, athletes have used those growth hormones. Erythropoietin, that was actually used by some cyclists several years ago. It just increased their body's number of red blood cells so they could carry more oxygen, and therefore they could compete more efficiently. That was what blood doping was all about, if you didn't know what that connection was. Prostaglandins, you can make note of these first few ideas here as you're reading through those, or not merely taking notes, but coming back and processing this after you've read through the chapter. Control of hormone secretions. Okay, I'm going to move myself, and then I'm going to have to come back to this. I'm going to slide off the screen a little bit. Let's see if that helps. Okay, there we go. Hormones can be short-lived, or it can last for a lot of days. We're going to see that kind of idea over and over. Control systems. This is negative feedback. So we're going to see that same negative feedback loop show up here again. And then so tropic hormones are going to operate in this sort of way. Nervous system control happens like this. And then this is how changes in our internal environment happen. So this is how hormones are going to be working. So that's that negative feedback control. Just to remind you, something happens to stop something. The pituitary gland. So you need to know where this is, and we'll look at a picture of that in a minute. And it's got two lobes, an anterior and a posterior lobe. That's enough for us to know. We don't have to know their fancy hypophoesis names. So look right here. See this inset? So if you sort of think from the base of your eye, or maybe at the top of the bridge, your nose here, not the bridge of your nose, top of your nose. If you kind of think going back, you can kind of picture where that is in your head, maybe. And then it looks like here's the anterior lobe, posterior lobe. It looks like two little sack of balls. Isn't that what it looks like? That's what it looks like. Little two. Yeah, I said it. So there you go. Okay, so here is the regulation. Anterior lobe regulation and posterior lobe regulation. This is the control here. So the hypothalamus is the big dog here, telling the anterior pituitary what to do. And then the anterior pituitary is acting on peripheral or outside the body endocrine glands. Anterior pituitary hormones. Let's be sure that you can pick out several of these. These are all at work in your body, so we'll take some more look at that. So these are the hormones from the hypothalamus. This is a really kind of interesting graphic because it allows us to see what the hypothalamus is sending out, then what's happening in the anterior pituitary, and then what that is acting on in the body. So things for growth hormones here, muscles, bone, and adipose tissue. Prolactin, that's just going to be for milk production. Thyroid, adrenal cortex. Remember, this sits on top of the kidney, and then ovaries and testes. So these are definition or summations, summary statements of what each of these hormones are acting on, what they do if you're confused about any of those. Okay, we're going to find that in a chart here in a minute too. So this is how we would see this action. The thyroid stimulating hormone is going to come out from the anterior pituitary gland, get into the bloodstream, go to the target cells in the thyroid gland, and then thyroid stimulating hormones happen down here. So you can see that whole process there. This clinical application, this is where growth hormones we have too little or too much. So you can take a look at that reading. Now, posterior pituitary glands, we only have two that are listed here for us to look at. So the ADH, antidiuretic hormone, that is going to reduce the amount of water or urine produced by the kidneys. And then oxytocin, which causes muscle contractions in the uterine wall for childbirth and milk to come out when during lactation. And guys, you don't have any function for that in your bodies. So here we go. This is the table that you want to take a look at for the action and the source of the control. Read through that, be familiar with some of these, or know how to use that chart to process some things, okay? So you got our thyroid gland here. Try to kind of figure out where that is in your body. You can feel your larynx and your larynx up here in your in your neck. Here, take a look at that. Iodine is important to that. There's just a slide of what that's going to look like. So you've got these glands here, the action and the control that comes in there. Hyperthyroid. These are disorders, hypothyroidism, Graves' disease. You might know someone who has one of these. So if you find this interesting, take a look at some of those. These are photographs from your textbook of different pictures. We don't see many people with goiters anymore. Those that actually gets taken care of pretty quickly now with surgery for these growths here. But that's in third world countries, we still see that. All right, the parathyroid glands. These are 4 glands on the posterior so these are on the back side. So know where they are and what they are. It secretes the parathyroid hormone. That's not super hard there. So you've got some actions here of this. So you can see as that goes down through how that operates. Again, that's what we're doing there. Some disorders here: hyperparathyroidism, hypoparathyroidism, the opposites there. Adrenal glands. So know where these are, closely associated with the kidneys. They sit on top of the kidneys. So take a look at that. It can be important with sodium levels. It has two sections. So it's got the cortex, which is this outer layer, and then the adrenal medulla is here on the inside. The hormones that we've got here, epinephrine and norepinephrine, these are really interesting, where these come from, what they do. So read through that. These are the hormones of the adrenal cortex. Okay, you don't have to worry about that. Yeah, we will not worry about these. Regulation of cortisol. Again, this is a negative feedback loop, so you're just processing here. Disorders, here's again, you might have, if you, especially if you used to watch House or something, this is Addison's disease, Cushing's disease. You might have seen some of these be mentioned before. The pancreas has both endocrine and exocrine functions, so please know that. And the three hormones that are coming from the endocrine cells are glucagon, insulin, and somatostatin. And look, kind of figure out where the pancreas is in your own body. So think about that. The pancreatic islets, that's this section right here, these little islands, the islet of Langerhans, posterior to the stomach, and it has, so taking care of the sugar in our body, and digestive enzymes. That's what's going to be happening there. So we can see here, what is the action of glucagon, what's the action of insulin, and then what's the action of somatostatin. Make sure that you know that. Then here is the negative feedback loop by which this happens, so you can parse through that. Take a better look at that. Please read the clinical application on diabetes mellitus. This is, it'll help give you an understanding of this. Also, the difference in type 1 diabetes and type 2 diabetes, and figure that out. What might you be at risk for if you are not currently diabetic, and later in life, not right now, and what can you do? So read a little bit about that. How do we treat it? So particularly type 2 diabetes, and looking at how do we treat type 1? What's the difference here? Does type 1 become type 2? Does type 2 become type 1? All right, so other endocrine glands, it's just like class, guys. I'm just going to mess up. The pineal gland, that one's also in the brain. You can't see. Here we go. In the brain. I can't even remember how to. Yeah, there we go. In the brain. The thymus, that's at mid in the thorax here. Reproductive glands, those are also endocrine glands. Read about stress and the effects of stress on the endocrine system. How do we respond to stress in these situations? How does the endocrine gland do that? And you see, so we've got words on the other one, graphics on this one. So take a look at that. This is our major events in the stress center. You will not have to order this or anything, but read through it. This can help you understand how your own body is operating and what might be causing something to happen in certain ways. Also, okay, the lifespan changes. So how is your body going to change over time related to your endocrine system? And there you go, guys. Those are the notes on the endocrine system.